Monday, we talked through this even and odd function sheet. We talked through one or two of these maybe hanging around the class when you come in. Number 1 and number 2 are hanging on the bulletin board. Number 8 is hanging over in front of one of the windows, and number 2 again is hanging over in front of one of the windows. So number 2 is hanging in the room twice. And I'm going to go through right now and I'm going to work out number 6 just in case that you're still having question. So number 6, the equation is f of x equals negative absolute value of x plus 6. Well, the directions say first thing for you to do is draw a quick sketch of the parent function and then sketch the given function in a different color. So I've gone through and I've sketched. I'm looking right here and I know that's an absolute value function. So I wrote down my parent function in black, absolute value of x. I'm also going to do number 7. Number 7, the equation is f of x equals 1/3 x to the 3rd power. The parent function is f of x equals x to the 3rd, and I've drawn it again in black, and I've got the original points for the parent function plotted. And number 10, I'm going to talk about f of x equals the square root of negative x plus 2. And again, I've graphed the parent square root function. Remember, 0, 0, out 1, up 1, out 4, up 2, out 3, up 9. And on the cubic function, the original x values and y values, you're at 0 when you're out 1, out negative 1, down 1, out positive 1, up 1, out positive 2, up 8, and out negative 2, down 8. On your absolute value original, you start at the origin, and you're out 1 either direction, up 1, out 2, up 2, out 3, up 3. All your y values are positive on your absolute value function. Now, the one that we're wanting to transform is f of x equals negative absolute value of x plus 6. Now, I go through and do my transformations first. That helps me to be able to graph. So I'm going to talk through the transformations. There's a negative sign, which turns me upside down. It's going to reflect across the x-axis because that negative sign is sitting outside the function. It is not inside that absolute value with the x. It is outside the absolute value, so it reflects me across the x-axis. So my transformation I have reflects across the x-axis. You need to write this down. This is part of your homework. So reflects across the x-axis, and then it shifts up 6. Again, that's outside the function, so it's vertical, is shifting up 6. If it were inside the function, it would be inside the absolute value it would be inside with the x, but that's not what it's doing. It's shifting up 6. So I know I'm going to take my original, and it's going to turn upside down, and it's going to shift up 6. So my vertex is sitting up at 6. I'm going to shift up 6. 1, 2, 3, 4, 5, 6. Now normally, from where my new vertex is, normally you're out 1, up 1, out 2, up 2, out 3, up 3. Well, in this case, it has turned upside down. It's a reflection across the x-axis. Now, in reality, the first thing that should happen is take this one and reflect it upside down. Vertex is still here. Absolute value graph is here. Normally, so this is it, turned upside down, and then this shifts up 6. So I've gone ahead and turned it upside down. Now I'm going to shift it up 6. So there's my vertex. And instead of me going out 1, up 1, I'm going to go out 1 and down 1 on either side. So that is my transformation. First thing that happens is I turn upside down. I reflect across that x-axis and then shift up 6. But for me to get it on my graph paper, I go and I do my vertex. And then remember, that's my new vertex. So I'm doing quotes here. My x-axis now, remember, is kind of sitting right there. So I turned it upside down. So there's the transformation of f of x equals negative absolute value of x plus 6. Now, let's talk about domain and range. The domain of this, there's arrows on both ends. Negative infinity all the way out to positive infinity is the domain. The domain of an absolute value will always be all real numbers. Doesn't matter what you do to it. If you shift it left or right or down or up, the domain's still going to be all real numbers. The range, however, will change. The original range, the black graph, that is my parent function. Remember, that domain is all real numbers, but that range is from 0 up to positive infinity. That's the range. The domain of the original is always negative infinity to positive infinity. The range is from 0 included, that 0 is on the graph, all the way up to positive infinity. But look at the reflected one. Look at the translated one. It has turned upside down, so the lowest y value here is not 0 anymore. It's negative infinity up to the highest point on that graph, and that highest point is sitting up here at positive 6, and it is included on the graph. So transformation, I've got domain and I've got range. Now, the original absolute value is an even function. Remember, even function is symmetric about the y-axis. This one is symmetric about the y-axis. This one has reflected across the x-axis, did not come off the y-axis, so it's still an even function, shifted up 6. So this pink graph right here is still symmetrical to the y-axis. So the translated function is still an even function. What makes an even function not be even anymore? The only thing that's going to do that, and these notes are hanging in the room, the even function, if it shifts horizontally, if it shifts off that y-axis, then it's no longer an even function. Okay, so there's number 6. This video is about 7 minutes long. I'm going to go ahead and stop it, and I'll do number 7 on the next video.